Okay. In this lab by codewars.com, we are looking at numbers. The numbers are inside the range defined by A to B. As you see here on the solution window with the function A to B, these are just the boundaries. Numbers can be anywhere from A to B. What we do is we will select one number from this range and we will look at the integers separately. So if it's a two-digit number, we will look at the tens digit and ones digit. If it's a three-digit number, we'll look at the hundreds digits, tens digit, and ones digit. And we will raise the digits to consecutive powers and add them up. Once we add the numbers up, the final result, if it is equal to the number we started with, the original number, then we call this number as Eureka number. I hope the pronunciation is correct. So Eureka number, this model or this problem can be explained here in this simple spreadsheet. Let's say we have a four-digit number, 4, 5, 6, 7, right? So 4,567, that's the number. So the indices for these digits are either index 1, index 2, index 3, index 4. So the power term is really, we take the number and we raise it to the power by the index number, right? And then, so basically I take this number here, 5, and to the power 2, okay? And here it is number 6 to the power 3, and so forth. All right. So here, this yellow, the green cell is summation of the power terms. And once we get the summation, we compare it to the original number. If the numbers are the same, then we call this number as Eureka number. So 4,567 is not an Eureka number. So let me show you another case here. Let's say 89. So the number 89 here, if you do the same operation, you get the same number here, 89, meaning that 89 is an Eureka number. Another one is 135. It's also an Eureka number. So the code, the lab is asking us to find out the Eureka numbers inside the range defined by A to B. And B can be a very large number, so it can be a huge number data set. Okay. Well, what we can do for that lab is we can, let's say, assign A as 1 and B as 10,000. And I don't want to use the terminal for the solution here because when I run it before the whole coding is complete, this will give me error message because this window is looking for specifically final answers and we are doing it progressively, so I cannot see the progress on that one. I don't want to get error messages for the code that I'm working on. All right, so that's why I move it to Colab. It's a Jupyter notebook. Okay, so the function is that. So I just take the function and develop that function over here. Okay, so what I will do first is I will have an empty list and I will call it Eureka, and that list will be the array where I will append the Eureka numbers. So my final answer, when I'm finished with the code, I will just say return Eureka, and that will give out the Eureka numbers. So it starts with as an empty list. So I will be starting with a for loop in range of A to B for the number. So I here represents the numbers, the integers from lower bound A to upper bound B. I have to be careful here because if I do it this way, this B, the last number is not included in the for loop because Python doesn't include that because Python starts with indexing from 0, so B is not included. So I will just raise it by 1 so that the last number is also included in the range, right? So this, let me put the column here. Okay, so this process is really a summation process of the power terms. So I will be doing the integration over the integers So this the integers integration, I will call total, and it will be 0 at the start. Right? Now, what I need to do is I need to integrate the power terms over on each digit, but as of now, I is an integer, and an integer is not iterable. In other words, the digits on the integer are not iterable. So what I think we can do is we can change the numbers from integers to strings. Python is very strong in strings. When we change it to strings, we can have we can start a for loop for the characters of the string in the iteration. So we can do that. So I would do a for loop for this time. I'll use j. J will be in range of the length of this string I. I hope that's correct. So basically, if I repeat what I've said so far, I'm changing this, I'm taking this number I or integer I between boundaries A and B, and I'm changing into a string. By doing so, I can iterate over the characters, over the digits, right? I say characters because when it's a string, they are not digits anymore, they are characters. And the length of this string will be your upper bound for the j iteration, for the loop defined by j. No. Okay, so once I do that, I will mimic this summation process here. I will just code this calculation with this yellow cell here. And to do that, I will just add the digits to total. It's an integration over all characters. So I will do the power term calculation for each character and add them up. So this plus is really doing that for us. So it's going to be giving us a value. So since this is a numerical operation, I have to do it. I have to change the power term calculation to integers before I do this integration side. So I will do everything inside integer function, built-in integer function. All right. So how I do that? I will take the this I value as integer, and I will look at the jth character. And then I will raise the digit to the power term, which is defined as j plus 1. And j plus 1 is really because on the first character here, j value here, the first character is 1, but the j will be 0, right? Because Python starts with indexing from 0. So by raising j plus 1, I'm changing the power term to 1. Okay. And when I do that, let me see the total. Okay, there is a mistake here that I need to fix, and that is for ij, and okay, I forgot to put in range here, I guess. Okay. Okay, I have IB. Okay, it seems that I am not getting an error message, meaning that I am able to switch to string to iterate over the digits and switch back to the integer to do the math. So I think everything looks okay. Well, what I will do next is I will check if this total number, the total, which is summation, which is this green cell here, that is identical to the integer we started with. if that is the case, I will take this number and append it to our list. Okay. With that, I have to write my return, and that should be outside of the for loop here, and I will just return the record. All right. Now, I couldn't see the print outcome here because I made a silly mistake. I didn't run the function because I have to run the function with the boundaries I assign. That should work. Okay. I think I forgot to put them in the right spot. Okay. There you go. Now, this array here is the Eureka array that is put together to show the Eureka numbers here. So all one-digit numbers are by default Eureka numbers. And when we go to this two-digit and more digit numbers, we have 89, 135, and these other numbers as Eureka numbers. That means if we take these digits and here raise it to the consecutive power and add them up, we get the same answer. So that is one way that I think can be helpful to get this special type integers. Right. I will check this with the other codes submitted on Code Wars and see if it makes sense. And I will also use the others to improve my Python skills.